Okay, so welcome back, and now we're going to talk about integrals again. Okay, so now we're going to introduce a new definition that's going to allow us to take what we've learned about Riemann sums and the limiting process, and now we're going to define what we call the definite integral. Okay, so it says definition 1. If f of x is a function defined on an interval ab, the definite integral of f from a to b is given by the integral from a to b of f of x dx, which is equal to the limit as n approaches infinity of the Riemann sum of the function from I equals 1 to n. Now notice here, this should be familiar, right? The integral. Okay, so we're defining the definite integral as the limit of the Riemann sums that we've been talking about. Okay, so notice that what's happening here is we're going from here, a limiting process, to saying, hey, this is the same as the integral, which you should be familiar with. Okay, except now we've got these endpoints here, a and b, right? Because we're on a closed interval. These are called the limits of integration. Okay. The last time when we introduced integrals, it was indefinite integrals. We didn't have any limits of integration. Okay, and that's where the constant came in. When we integrated, we always had to have that constant of integration. Well, now with the definite integral, we're not going to have any constants of integration because we're on a closed interval, and so we're actually going to be able to find a number. Okay, so we'll be able to evaluate these. Also, notice that as we go to infinity, the summation sign elongates and becomes this like elongated S. Okay, this S actually means summation, and I believe it comes from Leibniz. Okay, so it's not a coincidence that we go from sigma, which is a summation notation, to the integral sign, which also comes from a summation notation. Okay. Also, delta x. Remember, delta x is a change in x. Well, what happens when we increase n to infinity? The delta x is getting smaller and smaller and smaller and smaller, and so the delta x becomes this differential, right? Remember, small change in x. Okay, change in x, right? Remember dx and delta x? Remember that connection before? Okay, so we see it again. Okay, okay, so now, this is true as long as the limit exists. If the limit does exist, then what we say is that f of x is said to be integrable over the interval. So it's an integrable function. Okay, that's the other thing. We can call it an integrable function, okay, over the interval. So we can either say it's integrable over the function or that it's an integrable function, okay? And so that's the definition. Have a good day.